हेलो एवरीवन, वेलकम टू टुडेज लेक्चर। आज हम कार्बोक्सिलिक एसिड के जो डेरिवेटिव्स हैं वी आर गोइंग टू कंप्लीट दैट। ठीक है, सो द ओनली पार्ट इन द ऑल ऑफ द डेरिवेटिव्स व्हिच इज लेफ्ट इज अमाइड्स। ओके, बट बिफोर दैट let's take a look at one of the reactions which we forgot or which we did not take a look at in the previous lecture. This reaction is basically based on esters. This is called Cylon Condensation. ठीक है, this is based on esters, Cylon Condensation. So what happens in this reaction is there are two molecules of esters. They condense in the presence of sodium and xylene, and on acidic hydrolysis final product acylon is obtained. So basic reaction is two molecules of R C double bond O O R. ठीक है, let's consider these to be the same. If you put it Na xylene and H plus H2, so what happens in this final product comes out to be this. Final product comes out to be this. Okay, did you get this? Now how does it happen? So what happens is Na atom, and Na atom has the tendency to lose an electron. Let's consider that to be the first step. Na loses electron to get into its ionic state. Now what happens is, if we have these two molecules of ester, these electrons, basically you can write it like this. These electrons, they attack over here and Na attacks over here. So just consider it to be like this. Electrons attack over here because this is electron deficient carbon, and the electrons of this bond shift to oxygen, and then this moves and gets attached to oxygen. So we get this, something like this, 2R C O Na, O minus Na plus C dot OR. Did you get this? So this is like a carbanion free radical. Okay, free radical carbanion. Got it? Now this dimerizes. This dimerizes into this. So what will happen? R C O R O minus Na plus single bond O R. I mean the whole molecule will get replicated. This is what happens. This gets replicated. You know, the same molecule will come and get attached on it. So you will get this. Now again what happens is, since Na is there, this electron is shifted onto, this electron is again donated to carbon, and this particular leaving group goes out. Now you may say that why is it happening, because OR is not a very good leaving group, but then as far as all of these are concerned, this is not a very good leaving group either. R is alkyl group. It is a much stronger base as compared to OR minus. This will leave, and I have already told you that C double bond O, whenever some addition takes place on acids, like for example a nucleophile came, okay, let's say not acids but acid derivatives, a nucleophile came, this electron gets shifted over here and we get something like this. This is an intermediate. So what happens is this again gets shifted over here, and this L leaves as a leaving group. Got it? I've already told you that. Now from here you will get something of this sort: C double bond O, C double bond O, R. Okay, this is what? This is alpha diones. Okay, these are diketones. Now what happens is, again there is attack of 2Na. I'm writing it like this instead of this. Basically it is the same. So what we will get is C dot R O minus Na plus O minus Na plus. Now in this particular one, these two free radicals are on adjacent carbons. So when that happens, they form a double bond. Consider this: whenever two free radicals are there, free radical carbons are on two different free radicals. This free radical is on two different, how should I put it? This, there are two different free radicals. Okay, then they will combine to form a condensed product. But when free radicals are on adjacent carbons, they form a double bond. So both these form a double bond, and we get RC double bond C R O minus Na plus O minus Na plus. Now what happens is, if you hydrolyze it, you will get RC double bond C OH OH. Now this is enol, so what you will get is RCH C double bond O R. So this is the product. You will get that. Got it? This is called Cylon condensation. Okay, so this is the reaction. This is the last reaction in esters. Now let's take a look at, if you want to take an example, then we can take this as an example: CH3 C double bond O. Just replace R with anything. Let's say okay, and the same thing here and here. You will get CH3 C CH3 C H OH. This is what you will get. Okay, even if you change this, like you change it to C2H5, there will be no change in the product, because this particular R is getting lost. This particular R, let's consider this to be R dash. Let's do that. Okay, let me do that. If I see, once you have lost it over here, you don't have to worry about it in the subsequent steps. Got it? This is where we are. Cool? Okay, let's take a look at amides now. What are amides? Amides are the fourth acid derivatives with NH2 group replacing OH in the acid. So this is what this is what amides are. R C double bond O NH2. These are amides. Okay, so this group has been put instead of RCOOH instead of this. You can see that we have already gone through this. I don't have to again go through this. What more I will tell you is that this particular amide that I have written over here is primary amide, 1 degree. Okay, and we have seen the nomenclature of this in the beginning itself, so we don't have to really get into that. So this is 2 degree amide, and this is 3 degree amide. Got that? That's it. So we don't have to worry about these. Now let's take a look at preparation. Okay, and then we'll take a look at if we have some information about the physical properties. Okay, so how do we prepare this? First from acids. Okay, how do you do that? Like for example, if you treat an acid with ammonia, you get the ammonium salt. This is the ammonium salt. But if you heat it, like this will be true everywhere. Whenever you heat ammonium salt, you will always get amide plus water, H2O. Take that out, you will get CONH2. Got it? H2O. Got it? That's the first one. Second one, okay. Second is from acid chlorides. Okay, from acid chlorides, like if you want to create acid chlorides, you can also do it like this. You could have done it directly, but I just want to tell you something. This is called phosgene. Phosgene. With phosgene, you can actually create RCOCl, and from there, if you want to, like for example, NH3, so you will get this RCONH2 plus HCl. But you know, there might be 2 moles of this which might be required. Anyhow, so this is what you have. C double bond O NH2 and plus HCl. So this is what you get when you treat acid chloride with ammonia. Got it? And ammonia needs to be in excess, not just 2 moles. It needs to be in excess. Okay? You just need to do that. Got it? Cool. Okay. Cool. Let's take a look at anhydrides. From anhydrides. How will you prepare from anhydrides? Like for example, if you have the third from anhydrides, how would you do that? Everywhere you have to use ammonia. Like for example, if you have this, usually this is not written like this, this is put in brackets. If you are going to do that, so you will have to use at least 2 moles of NH3. From here you will get NC double bond O NH2, that is this particular portion. Okay, and the other particular portion will give you the ammonium salt of it. Okay, which is NH4. This minus, this plus. NCONH2, okay, NCOO NH4. Okay, so this is what you get, and if you want to get that again, you can heat it. So you can get 2 molecules or moles of RCONH2. So amides can be prepared from acid anhydrides by treating them with ammonia and then heating the products. Okay? Got that? That's easy. Cool. Okay, from esters, how do we do that? From esters. So with esters, what happens? Fourth, from esters. Okay, so what will you get from esters? Like for example, if you have this, let's say, and you have RNH2. Let's consider this to be the scenario. So what happens is this H from here, this is taken by this, and you get RC double bond O NH R double dash plus R dash OH. So this is what you get, and then the fifth one is from nitriles. Okay, from nitriles R C triple bond N. If you partially hydrolyze it, okay, you will get RCO NH2. Partial hydrolysis, ठीक है, partial hydrolysis. Got that? Okay. Cool. So write that. Nitriles on addition with water in the presence of cold concentrated HCl or H2SO4. So I told you acid hydrolysis in the presence of cold concentrated HCl or H2SO4 gives us amides. This addition is called, this hydrolysis is called partial hydrolysis. This hydrolysis is called partial hydrolysis. Got it? So both the things, you can do it with HCl as well as H2SO4. Got it? Cool. So these are the processes through which we can prepare acid amides. Got it? Let's take a look at their physical properties. Cool. Let's take a look at their physical properties. Physical properties, one of the most important ones is, apart from the first amide, which is formamide. What is formamide? Instead of R, just put H. Apart from formamide, all of the amides are crystalline in nature. Write that. Apart from formamide, all the other amides are crystalline solids at room temperature, full stop. They have relatively high melting and boiling points. Because of hydrogen bonding, intermolecular hydrogen bonding. Like that. Got it? So these are the physical properties. Now let's take a look at the acidic property as well. Let's take a look at that as well. Write that. Amphoteric character. So we have NH2. You will see that this N has one lone pair of electrons. Usually what happens, this one lone pair of electron gives this certain basic character. But what happens is, these two electrons get in conjugation with this carbon, okay, in resonance with this double bond, single bond, lone pair of electrons. If you remember correctly, in 11th standard, there were several cases in which conjugation would have taken place, and this was one of them. Double bond, single bond, and then lone pair of electrons. So this is what has happened. So these lone pair of electrons, they are in conjugation with carbon, or they are in conjugation with this double bond, hence their availability is a little reduced. Since their availability is reduced, the basic character of amides is a little reduced as compared to amines, where there is no CO. if you remove this CO, these lone pair of electrons will not go in conjugation with anything and they will be available to be donated. This is a Lewis base I am talking about. Lewis base are those species which can easily donate their lone pair of electrons. They can give electrons. Got it? So here, since these two electrons are in conjugation with this double bond, we can say that they are not completely available. Hence, the basic character of amides is a little less. But then again, if you look at the resonance structure, the other resonance structure, canonical form, you will find that there is positive charge on N. Since there is positive charge on N, what will this do? This will try to extract electrons from here, and when it tries to do that, this will go out as H plus. So it does have certain acidic, some acidic character, you can say that. So it has both basic character, which is basically low, and it has acidic character, which is also low. So both the characters are there, though in lower strength. That's what we can say. Write that. Right. Amides are feeble bases. Amides are feeble bases due to the involvement of a pair of electrons. Due to the involvement of a pair of electrons present on N atom in resonance with carboxyl group. Got it? Full stop. As a result, N atom receives a partial positive charge. As a result, N receives a partial positive charge, like in this one, due to which it shows feeble acidic character. Got it? Cool. Now let's demonstrate that acidic character. Okay. Let's say we have RC double bond NH2. If we react it with this, so what happens is, these two H from these two molecules and this O, this is basically an acid base reaction. This is a basic oxide. Let's be clear about it. This is a basic oxide. So this will behave like an acid. Okay. So what happens is RCONH whole twice Ca plus H2O. This is what we get. Got it? One hydrogen is acidic and it is taken up by this O. So basic acid base reaction is happening. Okay, na? So this is acidic character. This is showing acidic character. Got it? Then there is basic character. Okay, this is called basic character. Basic character, if you react it with HCl, what do you get? If you react it with HCl, let's say you're reacting it with HCl. So what will you get? R C double bond O NH3 plus Cl minus. Either you can write it like this or it can be written like this. Sometimes it is written like this, the way I am putting it over here. Okay, so don't worry about this. So is it going to be like this or is it going to be like the other? Okay, it can be any of these. Got it? So it shows both acidic as well as basic character, though very feebly. Got it? Let's take a look at other reactions. Now, chemical properties. In the chemical properties, you will find various reactions. One of the first reactions is the reaction with or hydrolysis of chemical reactions. Hydrolysis of, first write hydrolysis. Now hydrolysis. Okay, in this reaction you get acids. Okay, this way or that way. I mean, it can be acid catalyzed by acids or bases, and you will always get either acids or their salts. In this case, what will happen? You will get RCOOH plus NH4 plus, and in this case you will get RCOO minus plus NH3. Got it? So this is what happens in hydrolysis. You will get acids no matter what from because this is basically complete hydrolysis of cyanides. So for example, if you want to take you want to get the whole perspective on this, from here by partial hydrolysis we got to this level, we got to amides, and if you further hydrolyze it either of these ways, you will get the acid. In this case you are getting the acid, in this case you are getting the salt, acid, salt. So write that. On hydrolysis, amides give acids, corresponding acids, amides give corresponding acids or their salt, full stop. This reaction is catalyzed by both acids and bases. This reaction is catalyzed by both acids and bases. Did you get that? Cool. Fine. Let's take a look at the other reaction. This reaction is quite a simple one, but you don't have to really worry about the mechanism of this reaction. The other reaction, the Hoffman degradation of Hoffman bromide reaction, I will tell you the whole mechanism, but with this we don't need any mechanism. You just need to remember that this reaction does take place, one thing, and the mechanism of this reaction is really not clear even today. Okay, so reaction with nitrous acid, HNO2. So nitrous acid is a very unstable acid, so it is usually prepared in situ, like there itself, in the reaction itself. This is prepared like this. So if, for example, anywhere if you see this written, like if it is written like this, HNO2 or HONO or NaNO2 plus HCl, or you can use H2SO4 as well instead of this. But then again, if you see this, you will always get this COOH, okay, plus N2, NH2, N2, just a minute, N2 RCOOH plus RCOH, OH plus H2O. This is what you will get. Got it? So write that down, right? On reaction with nitrous acid, amides give the corresponding acids, with the release of N2 gas, There are questions on this. They have been asking several exams that whenever you react amides with nitrous acid, which gas is released? So it is N2. It's not H2O, it's N2. Got that? Cool. What happens in this one is basically you get, so HNO2 is this. There is some kind of, like, you get this NO plus. This is the electrophile you get, and you know there is some kind of a reaction here which gives you the particular products. Write that. The reaction proceeds via the attack of electrophile NO plus, attack of the electrophile NO plus generated from HNO2. My guess is basically this is what happens. HNO2. This is my guess in the sense, basically because other products are also obtained over here. So what happens is, this is like these two acids react with each other. This is not a very strong acid that it cannot behave like a base. So here it is behaving like a base, here it is behaving like an acid. This is what happens, and you get NO plus or NO2 minus. So these two species are present in the solution, but the products that we get are formed through the attack of this NO plus. So you just have to remember this much. Okay, you don't have to remember all these things. Nobody is going to ask that. But just to satiate your curiosity, I have told you that. Got it? Cool. Now, third is Hoffman degradation. Hoffman degradation. Okay, write that. This is very, very important reaction. In this reaction, we can Hoffman degradation, Hoffman rearrangement degradation, Hoffman rearrangement, or Hoffman bromide reaction. Hoffman Hoff लिख लिया मैंने. Hoffman bromamide reaction. Okay, so in this reaction what we get is an RC double bond O NH2, an amide, when it is reacted with Br2 in the presence of NaOH or KOH, any of the two bases, and these have to be cold. Okay, so we get R NH2 plus CO2 plus H2O. OBR, just wait a minute. RNH2, CO2, NH2. I think this is Br2 and KOH. Okay, no, not CO2. We get, because NaOH is there, so we will get Na2CO3 instead of this, and NaBr. This is what we get. Got it? So this is what you need to remember. Got it? If you want to write the balanced chemical equation, you can write it like this. This will be far better. RNH2, okay. NaBr to NaBr. Okay. Na2CO3 and Na2CO3. Okay, 2H2O. So this is your balanced chemical equation. Got it? So there are several ways in which the mechanism can be explained. I will go with one of them, which I found more logical than others. Okay, so let's write that. Hoffman bromamide reaction. Amides react with bromine. Right, amides react with bromine in the presence of alkali. In the presence of alkali to form primary amines. To form primary amines having one carbon atom less than the parent amide, having one carbon atom less than the parent amide. So you can see that, let's say there were n carbons in this alkyl group and there is one, so there are n plus 1 carbon atoms, but in this one you will find only n carbon atoms. So this particular reaction can be used to move down the homologous series. So if you have, let's say 11 11 carbons in a particular amide, if you want to change it into, let's say an amine of 10 carbons, you can do that with this reaction. Got that? Very, very important reaction from the point of view of your boards as well as JEE. Got it? Okay. So this is the mechanism. Okay. RC double bond O N H H. Now here is what we have. This is a base. This takes this acidic hydrogen and we get RC double bond O N H minus. Now this, okay, what happens is Br2, this nucleophile takes this bromine, which is Br plus, okay, Br plus from here, and gives RC double bond O N H and Br. This is what you get. Got it? Now again, this OH minus, which is a base, can take this acidic hydrogen. Now you have Br attached to this, then you know this nitrogen becomes, this hydrogen becomes more acidic. So we can get RC double bond O N Br minus. Okay. So what happens is, here this is particular, this rearrangement is called Hoffman rearrangement. This rearrangement is called Hoffman rearrangement, and this is what happens. And the moment this happens, Br goes out as Br minus. So Br minus is going out as Br minus. Oh, sorry, Br is going out as Br minus, and there is a rearrangement taking place. Now what happens in this rearrangement is R goes to N, taking electrons of this bond. So there is positive charge on this carbon, and the negative these electrons, they are getting in bond with this carbon, because this carbon has positive charge. Now just for the time being, let's remove this R. If we remove this R, what will we get? C plus and N minus. We can actually make a bond over here. Okay, so what happens is, this particular rearrangement takes place is key. If we want to make it, let's say its transition state will be somewhat like this. Okay, its transition state will be somewhat like this. Let's do it like this. I am going to make the bonds which are getting broken with red. So this bond is getting broken, this will be in red. This bond is getting broken, this will be in red, because this bond is getting broken, and this bond is getting formed. Which one? This one. And then again, this double bond is also getting formed. So if F हो गया, ये F हो गया, ये B हो गया, ये wait a minute, B, and this bond will be F and F. So this is getting formed, these are getting broken. So we get something called isocyanate, and we have already seen this a few times. This is called isocyanate. Got it? If we get this, then we get isocyanate. Just a minute. Okay, RCuNO and Cu isocyanate. Just a minute. Now if we treat it with water, okay, Even if we don't treat it with water, it doesn't matter. But again, let's keep OH minus only. If we treat it with OH minus, it will attack on this because this is the most positive center over here. Now, some people will say this bond should go and should break and the electron should go to O. Some people will say that it will go to N. So, for those people who are saying that this will go to O, what happens in this case when the electrons actually go to O, they again come back and these electrons move again to N. So there is nothing that is going to happen if we move in that direction. Let's take this one only where these electrons are getting moving to N. So when they move to N, we get what? R N minus C double bond O O H. Now this is acidic. This is an acid. And what is this? This is a base. What is this? This is a base. This is a derivative of this base NH2, which is a very, very strong base. If I write it like this, does it become even more basic? Yes, it does. So this is very, very basic, and this is an acid. What happens is this H gets shifted over here. So we get something like this, NH C double bond O O minus. Got it? So in a split second, what will happen? This happens and we get this RNH2 plus CO2, and we had already gotten water out. We've already taken water out. So what will we get? RNH2. From here we can get CO2, which again reacts with NaOH to give Na2CO3. Got it? So you don't really have to worry about it. Where are we going to get these two? You will form these because NaOH in when there is where is that? There is Br minus as well. There is Br minus as well. So Na and Br will form NaBr. NaOH will react with CO2 to form Na2CO3. So basic thing is that you have to remember that this what happens, what are the products and how it happens, okay, through the formation of isocyanate. And this on reaction with H2O, I have written it OH over here. In some books you might find that to be H2O over here. Even if it is H2O, you will get the same products, though with a little more steps. The guy will have to show one more step apart from whatever I have shown. Got it? Cool. So write that. Right. Amides with no substitution on nitrogen. Amides with no substitution on nitrogen react with a solution of bromine or chlorine, react with a solution of bromine or bromine or chlorine in NaOH or KOH to yield amines. This is called Hoffman Rearrangement, or you can write all the three names. This is called Hoffman Rearrangement. That is first thing. And right. Now write this. Usually this reaction takes place in non-aqueous conditions, but we carried it is carried out in the presence of water or aqueous conditions, because as soon as this is formed, it will react with water and form the product. If you want to isolate this, then you can do it in a non-aqueous medium. Okay, so write that. Isocyanate can be isolated. Isocyanate can be isolated by carrying out this reaction in anhydrous conditions. by carrying out this reaction in anhydrous conditions. To obtain the product, we do it in aqueous conditions. Got it? Cool. If we were to do it in alcohol, in the presence of alcohol, write that. If this reaction is carried out, okay, if this reaction is carried out in the presence of alcohol instead of water, we get urethane. Like for example, if we react it with this, what happens is, you have to write another one. Forget about this one. Got it? So this one will attack over here, and you will get something of this sort. NHCOR. Got it? This is called urethane. You can see that this is an ester and some crossover of an ester and a amide. Got it? This is called urethane. Cool. Sometimes this particular thing is written as, right, we have written it Br2 plus KOH or Br2 plus NaOH. We have written it like this, or sometimes this is not written. Sometimes it is written like this. So sometimes it is written like this: RCONH2 KOBr, or sometimes it is written like this, OBr minus, and the product basically is the same. I'm not writing everything. RNH2 plus, let's say, CO2. Got it? How does this correspond to this? So write this equation. This is very, very important. Whenever Br2 and KOH are treated, okay, or kept together, like for example X2 and OH minus, I'm giving you a very, very general reaction. If this OH minus is cold and dilute, you will always get something like this. Okay, and whenever this OH minus is hot and concentrated, you will always get X minus plus XO3 minus. Okay, so here we will put NaOH or KOH in cold and dilute condition. Since we do that, we get XO minus. Okay, if X is Br, okay, we will get OBr minus, which is what here is. Okay, sometimes it is just given like this. You have to recognize this in the reactions so as to be able to solve the question. If you do not know what this reagent will do, you won't be able to create the product. And that's what happens during your mains and NEET exam basically, because in board exams it is usually given, like, they will say write the Hoffman bromide reaction or explain Hoffman bromide reaction, or maybe the mechanism of Hoffman bromide reaction. That's what they will ask you, nothing more. Got it? Cool. So cool, let's move on. Dehydration, that is an important reaction, and then we'll move on to reduction. Reduction is also a very, very important reaction over here. Dehydration can take place in two or more ways basically. Hoffman degradation. This is the third, and this is the fourth one. Fourth one is reduction, another one is dehydration. Yeah, dehydration. Dehydration can take place if we treat amides with any of these: PCl3, SOCl2, or लिख रहा हूँ PCl5 or P2O5, which can be written as P4O10. Basically it is P4O10, but we write it as P2O5. This is clearly a dehydrating agent, so we don't really have to worry about it. We will get cyanides. So on hydrolysis, partial hydrolysis of cyanides, we get amides, acid amides. But when we dehydrate it, what will happen? Hydrolysis means addition of water. Dehydration means removal of water. So if we remove water out of it, H2NO, we get RCN. Got it? So a very short mechanism of this will be somewhat like this: minus 2HCl plus PCl5, and we will get RC double bond O N PCl3. Got it? So okay, if we move it over here, this is what happens. This gets shifted, okay, and we get RCO minus double bond N PCl3. So what happens is, this is the negative part and this is the positive part. Finally we get RC, like this bond gets shifted over here. I think it's just a second. This bond again gets shifted over here, and this is taken out by this. So we get RC triple bond N, which is cyanide, and then we get POCl3. So there is some kind of a attack between PO and O, which I don't want to show. Just this should be enough for this. Got it? So this is what dehydration is, and these are the kind of dehydrations you can look for. Got it? Dehydration is done. POCl3, P2O5, SOCl2. Cool. Let's take a look at reaction. Reduction is a little different from others. Fifth one is reduction. Okay, reduction is like, if we ever have this, what do you think can be reduced from here? What do you think can be reduced from here? This is already in the reduced state. This gets reduced into RCH2 NH2. You can put NHR over here, NR2 over here, you'll get the same products. So what I'm going to do is, I'm going to put a whole list of reducing agents over here. Got it? If we have this, even if we have this, you will get RCH2 NHR. Okay, and if you get C double bond O, NR2 RCH2 NR2. Got it? So what you can do, you can have Li ALH4, you can have Na C2H5 OH. Okay, what else can we have? BH3. Got it? So these are some of the, or I'm writing or, because it can happen just with this or with this or with this. So here are the reactions of amides, and acid derivatives is complete over here. Got it? Let's see how much time is left. Cool. Let's complete it for the day. Let's call it a day. Tomorrow, or in the next lecture, we are going to take a look at cyanides and isocyanides. So we are going to complete that. Cool. Chalo, bye bye. Take care.